Welcome everybody, and thank you for joining us today for the second installment in EnSafe's Client Education Series webinars. My name is Rich Heinzenberger. I'm a project manager here at EnSafe. And today's topic is titled Occupational Noise Assessment and Data Interpretation. And it's being presented by Bayless Kilgore. Bayless is a certified industrial hygienist and certified safety professional out of EnSafe's Bowling Green, Kentucky office. He also serves as an associate principal here at EnSafe and is the operations manager for our health and safety group. I would like to remind you, if you do have any questions during our presentation today, to submit those via the Q&A function in your toolbar on your Zoom screen. And we'll try to get to as many of those as possible towards the end of the presentation today. Once again, thank you for joining us and welcome. And I will turn it over to Bayless.
Thank you, Rich. I'll attempt to share my screen here. Well, thank you for the introduction. And again, thanks everyone for joining EnSafe's educational series. Hope you got to attend last week's, and we have several more coming up, so be sure to sign up for those. As Rich mentioned, what I'd like to talk about is noise exposure monitoring, personal noise dosimetry, how to interpret the data, look into the OSHA regulations. This would be the point in time if I was leading this live, which I honestly would much prefer, so I could see the audience. I would kind of inquire and ask, kind of what's everybody's experience, what they're looking for out of a presentation. But I presume if you're here today, you're an environmental health and safety professional or a safety industrial hygiene professional that's hoping to pick up a little tidbit about noise exposure monitoring. And so I'll do the best I can. And like Rich said, you can submit questions, and hopefully we'll have a little bit of time at the end to go over those. So this is the outline, just to talk about the effects of noise exposure, how to quantify it, how loud is it, look at the OSHA regulations, and specifically how the noise exposure standard came about. I think that's really interesting, and it's actually important in understanding, how to interpret things. We'll look at the general procedures for doing the monitoring, the monitoring instrumentation, some of the pros and cons, and then lastly, and most importantly, how to interpret the data. So most everybody's probably seen this depiction of the human ear and hearing, and it's important though to look at this and understand it. Everybody understands, think that, okay, loud noise is what causes hearing damage, but let's kind of dive in a little bit deeper and talk about how that happens. You can have extremely loud impact noise, like if you hunt, you're shooting shotguns or rifles or something like that, that can damage your hearing. But probably more commonly is just elevated noise levels. And it can be, fairly loud, but not extremely loud, but being exposed to that day after day in your work environment. That's typically, where that is by far where you're going to see the most occupational related hearing loss. But looking at the human hearing, the sound comes in, and I think it's important to refer to it. It's not necessarily as noise, but it's sound pressure levels. So these are pressure waves that are coming into the ear canal, just like dropping a rock into a still pond or something, watching the waves come out. These are sound pressures that are impacting and is what our brain interprets as sound. So the vibrations from the eardrum set these ossicles in motion, and they're these three tiny bones. They're actually the tiniest bones in the human body, known as the common names, the hammer, the anvil, and the stirrup, just by the way they're designed. And the ossicles amplify the sound and send this information into the cochlea. And inside the cochlea are thousands of microscopic hair cells called cilia, which are set in motion when the fluid inside the cochlea is disturbed. So that stimulation in turn causes electrical impulses to be sent to the brain. So what happens with occupational noise and hearing loss is that these sound pressures that are coming into the ear are bigger than is safe for the cochlea to handle those, and essentially damages those tiny cilia. And the best analogy that I've heard is it's kind of like if you get out in your vehicle and you want to walk into a building. Well, the sidewalk kind of takes a long way to get there, and the straightest way is just cutting across the lawn and walking across the grass. Well, if you do that once, you walk over and back, you might see footprints in the grass, but okay, no problem. But if you do that day after day, multiple times per day, pretty soon you're going to have a path with you killed the grass, and you've beaten it down. So it's kind of the same thing that happens inside the cochlea. These sound pressures come in with such force that they essentially kill the cilia, and it's not going to grow back. So it's that's how hearing damage occurs. I think the takeaway is that the human ear and the ability to hear is incredibly complicated but very delicate. So it's something that needs to be cared for. Everybody's seen these loudness charts, and I don't want to spend a lot of time on this, but this one goes from 0 to 110. There are noise and sound levels that are, typically you'll see these, they'll go up to like maybe even to 140. But this is quite a range, and I'm going to talk about what is a decibel here in a second. But 0 is the lowest threshold of human hearing, and you're okay. The ear can handle the sound pressure levels that are coming into it without damage, typically going up to around 80 decibels. But once you start getting up above 80 decibels, and again, there's just some common examples, the sound pressures coming into your ear are such that it will start damaging that cilia that we talked about. So of course, the higher you go, the worse it gets. So again, noise levels or sound pressure levels up to around 80 are okay. Once you start getting above that, then you start having trouble. So what is a decibel? Now the kind of the textbook definition is it's a dimensionless unit used to express the logarithm of the ratio of a measured sound quantity to a reference quantity. And that reference quantity, again, it's a measurable sound pressure level, is that quantity that a young person with perfect hearing, when they can barely start hearing it. And so it's a mathematical formula using logarithms that you take what the actual sound is and divide that by the reference that someone with perfect hearing can hear, and that kind of tells you, how loud it is in decibels. And it's not you can't add decibels together just algebraically. So 2 plus 2 decibels does not equal 4 decibels. In fact, every doubling of sound pressure levels is a 3 decibel increase. So in this case, 2 decibels plus 2 decibels is going to equal 5 decibels. 70 decibels plus 70 decibels is going to equal 73 decibels. 100 decibels plus 100 will equal 103. So each time you double it, you're just adding 3 decibels. So, again, you kind of go back to that scale, 0, in this case, up to 110. You can think every time you go from, say, 80 to 90, it's not, 10 decibels doesn't sound like that much, but that's over 3 times the power there. So they're just, it's a good way to put it in perspective. So another term you've heard a lot, I'm sure, if you've looked at the OSHA regulations or you've received a noise monitoring report, you'll see that that it's referred to as dBA. So dB is decibels and A. So what is this A stuck on the end? Well, the A, it's the A scale, and that's designed to mimic the susceptibility of the human ear to noise. So essentially, the human ear is not damaged as much from lower frequencies, which, below 1,000 hertz, and these are octave bands across the bottom, as you see here, as it is to higher frequencies, especially in the 2,000 to 4,000 hertz range is where the ear and specifically the cochlea is most susceptible to damage. If you think again, try to think of it as sound pressure waves, and instead of just calling it noise. These pressure waves are a certain frequency, and this 2,000 to 4,000 hertz, just the way that cochlea, which is kind of a circular little organ, is impacted more by those short frequencies more so than the long ones. So what this dBA or this A scale is that if you had these pure tones, and these are octave bands, with a certain sound pressure, say at 31.5 hertz, then the noise dosimeter or the equipment is subtracting 39.4 decibels off of that sound pressure because it's just, the human ear is not that susceptible to it. But conversely, at 2,000 hertz, it's adding 1.2 decibels to whatever that sound pressure is because the human ear is more susceptible and in that frequency. And if you've ever seen an audiogram from someone that has noise-induced hearing loss, you'll see that it typically has that notch in the 2,000 to 4,000 range, and that person's going to have trouble hearing things like rain falling on the roof, birds singing, and also understanding speech, because human speech is in that 2,000 to 4,000 hertz range as well. So that's why the OSHA standards and pretty much all noise measurements are always quoted in dBA. Let me get a drink of water here. So I find the regulatory history pretty fascinating, and I want to cover that just because it kind of lays a framework for the current noise standard as we have to comply with today. So the Walsh-Healy Public Contract Act back in 1969 added the occupational noise exposure standard as an amendment. It had a lot of stuff besides the noise exposure standard, but it was a Public Contracts Act that contractors to the federal government had to abide by. So they added this occupational noise exposure standard as an amendment, and it was based on the American Conference of Governmental Industrial Hygienists, that ACGIH, the threshold limit value that was in effect at that time. So a lot of the air contaminants and noise standards, everything was, when OSHA ended up adopting everything, was really based on the ACGIH TLVs at that point in time. So in around 1970 was when OSHA was enacted, and in 1971, OSHA adopted this Walsh-Healy standard, which originally just applied to contractors that were doing work with the federal government. So they adopted it as the noise standard, and then it applied to general industry at that point in time. So the original noise standard in 1971 was, if you look up 29 CFR 1910.95, was just paragraphs A and B. That was it. That's all there was to it. And that's where they had the permissible exposure limit, table G16, if you looked at the noise standard. So it was 10 years afterwards when they finally enacted the Hearing Conservation Amendment, or added, I should say, the Hearing Conservation Amendment to the noise standard. And that added paragraph C through N of the noise standard. And that's where you have to have a hearing conservation program. And we're going to talk about all that in a minute. So that's kind of the history of the noise standard by OSHA. So looking at the original noise standard, again, this is 1910.95 A and B, which is, original, but it's still in effect, has the permissible exposure limit, the PEL, which is 90 dBA as an 8-hour time-weighted average, and this correlates to 100% dose, which is a criterion level. You'll hear me talk about these terms over and over. One thing that you might not know about that, but only noise 90 dB and up is included. So noise 90 decibels, below 90 decibels is not included in the measurement, which, I'm not sure why that was the case, but that is the law right now in the OSHA standard when you're trying to compare results to the OSHA PEL. And what the standard says that if someone has an exposure, with the dosimeter set at the proper settings, if exceeded, it says, quote unquote, feasible in administrative and engineering controls shall be utilized to lower the exposure to below 90 dBA. But if not feasible, then you have to use PPE, which is basically hearing protection. So the question is, what is feasible? And per OSHA, if the cost for engineering or administrative controls are higher than just using PPE, then they're going to allow hearing protection to be used. But they basically say, again, in their field operations manual, that once a time-weighted average exposure is above 100 dBA, then hearing protection really is, you just are not going to be able to get enough hearing protection to lower that exposure to below 100. And we're not really going to get into noise reduction ratings and all that, or we'd probably be on here for a couple of hours. But basically, OSHA's really not going to cite you for that. From the current field operations manual, I'll read this. It says, current enforcement policy regarding 1910.95B1 allows employers to rely on PPE and a hearing conservation program rather than engineering or administrative controls when hearing protectors will effectively attenuate the noise to which employees are exposed to acceptable levels, which is, basically below 90, where someone's here had a standard threshold shift. Again, it's another little tweak in the regs there. You'd have to get it below 85. Keep in mind, some states have their own state plan states. They're more stringent than federal OSHA. Now, with all that said, as a CIH, and as a company, we highly recommend that if you have elevated exposures, TWA exposures, employees exposed above 90 decibels, we highly recommend following the hierarchy of controls, which is, as we all know, engineering controls are way, way above using PPE, and PPE is the last resort. So there's a lot of really, really neat ways to reduce noise and sound coming from equipment. And so we would highly, highly recommend that you look at reducing the noise, even though OSHA might not cite you for it. So we'll look at the OSHA action level. And again, this is the Hearing Conservation Amendment, which was added in 1981. And this is paragraph C through N. The action level is an 85 dBA as an 8-hour time-weighted average, and this corresponds to a quote-unquote 50% dose. The criterion level of 90 is still the same, but the one important thing about this is that now noise from 80 decibels and up, it actually says 80 to 130, but that's for all practical purposes, it's 80 decibels and up, is included in that integration when you do noise monitoring. So anything below 80 is not, but 80 and up, whereas for comparison to the OSHA PEL, it's 90 and up. And again, the original noise standard with those requirements to do monitoring in that form with those settings is in place, and the requirement to do the monitoring with the noise dosimeter with 80 decibel threshold in order to compare your results to the action level. So there's two things going on here now that you have to do. And the standard says if the exposure is at or above, so it's not above, it's at or above the action level, then you have to have a hearing conservation program, and you have to do, your baseline audiograms, annual audiograms. You have to offer hearing protection. You have to do training. So that's all applicable under the OSHA action level. So hearing protection must be offered, it says, if the exposure is at or above the action level. But it says that it's not required, it's not mandatory unless the employee has not yet had a baseline audiogram. So if the employee hasn't had a baseline audiogram, then they do have to wear hearing protection if their time-weighted average exposure is 85 or up. Or if they've experienced a standard threshold shift, which again, that's a defined term there in the OSHA standard, but it basically means they've suffered hearing loss in the workplace there. And so if they've had a standard threshold shift, then they must wear hearing protection. I can tell you from a practical standpoint, and I think every company that we work with, if the employees' time-weighted average exposures are 85 decibels and up, then they just go ahead and require hearing protection, period. It's easier to enforce, and certainly it's actually needed to provide an adequate level of protection. So is monitoring required? You might be wondering, well, we have some noise in our facility, not done monitoring. Can I get cited by OSHA if I haven't done any monitoring? I offer hearing protection, but haven't done any monitoring. So this is what the standard says. It says when information indicates that any employee's exposure may equal or exceed an 8-hour time-weighted average of 85 decibels, the employer shall develop and implement a monitoring program. So that's your answer right out of the standard. So yeah, if you think it's 85 decibels, then you do have to monitor for that. So what is it? What is 85 decibels? So the rule of thumb is basically, if you have to raise your voice at arm's length, roughly 3 feet to understand what someone's saying, then the noise level at that point in time is likely 85 dBA or higher. So now I want to look at the types of monitors for monitoring noise exposure. So one of these is different from the others. So we'll start with the one up in the upper right corner. That is a handheld sound level survey meter. So this is one that you hold in your hand, you walk around, you measure the sound levels in a facility. It's not worn by an employee. It's one where you do your area sound level survey, which I'll talk about in a second. The other 4 are personal noise dosimeters. Now the 2 over here on the left at the bottom are the old Quest, I think Q300s. Really good durable dosimeters, and they're still out there. You can rent them, but you're not going to buy them new anymore. But they're good dosimeters. It's just another thing that the employee has to wear on their belt. So when they came out with these little guys like this Casella up here at the top, and this Quest 3M, I guess it is now, or Honeywell maybe, the Edge. They have the microphone kind of built into the unit, and so it's placed upon the employee's shoulder. They don't have another thing on their belt, so it's the employees certainly like wearing these a lot more. And we frequently, when we're doing air sampling, we'll, when most every site has noise exposure, so you can kind of get a 2-for-1 there. You can do the personal noise monitoring at the same time without having too much equipment on an employee. Let's talk a little bit about what is an area sound level survey, also known as noise mapping. So you basically take this handheld sound pressure level meter. Again, it's, we're monitoring for noise, but you're really monitoring sound pressure levels. So you take this meter and you walk around, you hold it out at arm's length away from your body at like a 45-degree angle. You need to get a facility diagram, something like an emergency egress map or whatever that shows the footprint, and you literally just walk around and you record the numbers and you write them down on the map. And so this is very helpful to kind of help you delineate, okay, what areas do we need to require hearing protection? As I said earlier, the OSHA standard just says, well, you have to offer it if it's above 85, but not 90. However, again, I would highly recommend, and every company that I work with, they just go ahead and require it if it's 85 and up. So that's very helpful. Now, if you have, say, a room or an area where it's maybe well above 80 in certain locations, but then you have somewhere that's below 80, 85, I should say, it's usually just easier from an enforcement standpoint just to say, okay, if you go in this room, you go beyond here, you got your little sign up, hearing protection required. It's just easier to enforce that way. If you're doing one of these, I would also monitor locations that don't have a lot of noise, just to document, hey, in a certain area, in a warehouse area of the site or of the plant, it's only 65 or 70 decibels. So yeah, we're not going to have to require hearing protection in those areas. And it's also important to note, because some plants, their noise levels are consistent in an area, but then you have maybe a big air compressor that kicks on and off. So if that's the case, or some other noise source that's kind of intermittent, you need to kind of document that and make a note on the maps, like, okay, it's it's 95 when the air compressor's on, but it's 85 when it's off, or something like that. So the more information you have on there, the better. And these should also be set to A scale, and which that is going to come from the factory that way. So now we'll talk about personal noise dosimetry. So this is what is really needed to determine compliance, because when you're doing the sound level survey with your meter in your hand, you're not really measuring exactly what the employee is hearing, because even if you think you're getting a representative number, sometimes employees have to get really up in and close to machinery, closer than you might think they need to. And so noise is a function of distance. So their exposure could be higher than what your sound level meter indicated during the area sound level survey. So when you do personal dosimetry, you take, again, this is a picture of a Casella. There's several brands, they're all good. You put it up on their shoulder, and they wear it. This is called the hearing zone. It's, just up on the shoulder there, within maybe, within a 12-inch sphere. And they wear it for the full shift. So you put it on them, they basically wear it all day, and then you take it off, and it integrates all those sound pressure levels, and it spits out one number for you. And that's used to determine compliance with the noise standard. So, and again, you have to monitor if your exposure could exceed the action level. And one thing I will caution, because we have this routinely asked of us, it does not record speech, so if you're going to do some monitoring for your employees, be sure to tell them that this thing is not recording what you say, it's only recording sound pressure levels. So make sure that's clear if you're doing monitoring. And I will say also that it's really important that this be mounted right up on the apex of the shoulder, and that it stays there as much as possible, because if it slides down and next thing you know, it's on front of the person, on their chest, you're getting some reverberation, some other things that can affect it. If you have an employee with a big, loud, booming voice, if it's kind of down in this area right here, it's, you know, a lot of times they're speaking into it almost. So it really needs to be up here on top of the shoulder. And one other thing, just a little tidbit, is if you have employees like especially maintenance that have walkie-talkies, two-way radio, sometimes keying the microphone, we've seen that has interfered with our noise results. We've got some really kind of quirky results, and we determined that was what was causing it. So next step would be to develop a monitoring plan. So how do I develop a monitoring plan for my facility? It's really the same principles as you would follow for your air exposures. You would identify similar exposure groups, and this is best done by, you know, looking at the different departments, and then the job titles or job positions, the descriptions of what they do. So let's say that you have at your plant, you run 3 shifts, and, you know, on each shift you got about 100 employees on the floor, out on the production floor during each shift. So do you have to monitor all 100 employees? No, you do not have to monitor 100 employees. That's where you break it down and you say, well, we've got this group of operators, same job descriptions. We verified they do the same thing essentially. So if we monitor one person out of that group, out of this SEG, then it should represent the exposures of the rest of them. And so that's the way you need to go about it. And conversely, even on different shifts. Now, ideally, yeah, it would be great to monitor on the different shifts, but sometimes it's just not practical to do so. But you can monitor the first shift. You know, we frequently are told it's like if you know, the first shift's where it's the loudest, there's the most activities, it's going to be louder then than it is any other shift. So you can do that monitoring and then share the data with other personnel on other shifts that do the same thing. And then you can make your judgments on who needs to be on the hearing conservation program just by monitoring these SEGs. And it's recommended to sample at least one person in each SEG at the plant. And I would also include personnel that work in quiet areas, because it does not cost that much more to put a noise dosimeter on somebody working in the warehouse. And sometimes you're surprised with the fork trucks with the beeping horns and different things. You end up getting some exposures that are right at the action level that you might not think about, because you think, well, it's really not that loud, but they're sitting there beeping their horn every time they go around a corner, and it adds up over the shift. And I would also say to don't forget your supervisors who are out on the plant floor as well, because sometimes they spend a considerable amount of time in the area. So you have the question, should you monitor employees that have little exposure to noise? Yeah, as I mentioned earlier, not required to, but certainly good to have that documentation in your files. Okay, so now that you do this, how frequent should you monitor? That might be the next step. We did a baseline, and so we have a good idea what our noise exposures are. And I think the way to answer that, the standard doesn't really say, it just says you have to have a monitoring plan and you have to monitor. So the question is, how confident are you that 1 8-hour shift represents the exposures at the plant? So typically we see companies usually do their plant-wide monitoring, you know, every 2 to 3 years. But you kind of think of it this way: if you run 24/7 and you have 3 shifts and you have someone come in, or you do noise monitoring, so you're only monitoring what's going on during that 1 shift. So if your exposure at your plant is uniform from 1 shift to the next, from 1 day to the next, it's like it doesn't vary, then you know, then you feel good that you characterize that exposure. But if it is variable, keep in mind you're only, you know, your numbers are only as good as what was going on that day. So one other thing, so what if a person is only exposed to an 85 dBA time-weighted average exposure once a year, you know, would that person have to be included in a hearing conservation program? There's a letter of interpretation from OSHA that says yes, that even if that person is exposed to an 85 decibel dBA time-weighted average exposure once a year, literally once a year, they would have to be included in the hearing conservation program. Now, from a health perspective, that really doesn't make sense, but that is OSHA's position on that. So I want to look at some of the key definitions, and this is where it starts getting a little bit complicated. But if you're going to do noise monitoring, you really have to understand it. And some of this we went over already. But the threshold level is the level at which the meter starts to measure noise. So your dosimeter is going to come from the factory. If you buy one, probably any that you buy today, you know, they're probably going to be factory set the way they need to be. But just keep in mind the threshold level, that's the level at which the meter starts to measure the noise. And we mentioned that earlier, the 90 decibel threshold for the original noise standard and 80 decibel threshold for the Hearing Conservation Amendment. And the criterion level from an OSHA perspective is that level that the results are compared to. It represents 100% dose, and that is 90 decibels for OSHA. And then the exchange rate, which we'll talk about quite a bit here, is the increase or decrease in decibels, dBA, corresponding to twice or half the noise dose. And that's a critical thing that really makes a difference. So let's look at the OSHA compliance settings. And again, if you get a new noise dosimeter, it should be factory set, but you really need to check it, because if somebody is messing with it or whatever, you could get off. But whether you're monitoring for comparison to the original noise standard or the Hearing Conservation Amendment, it's going to have exchange rate of 5 decibels. It's going to be set to the A scale, needs to be at slow response, and the criterion level is going to be 90 dBA. What's different is the threshold levels. Again, hearing conservation is going to start, it's going to start integrating those sound pressures that are 80 decibels and up, whereas the engineering controls is only going to be 90 and up. And something that I found interesting, that when I was looking into the history of the standard from OSHA, in 1972, NIOSH published recommendations for an OSHA occupational noise standard to update it, which included an 8-hour TWA exposure of 85 dBA, but they said keep the 5 dBA exchange rate. So they did. In 1973, they maintained the original 90 dBA PAL with the 5 dBA exchange rate. But what I wanted to mention is why the 5 decibel exchange rate, because mathematically it does not work. It does not work with logarithms without, you know, with a little work. So even with noise energy exposures, it doubles every 3 dB. OSHA thought it important to account for the time during the workday that a worker was not exposed to noise hazards, which seems kind of odd now, but that's why they chose 5 dB exchange rate instead of 3, to account for the time that they're taking breaks, that their equipment is down. And at that time, back in the 70s, using a 5 dB exchange rate was viewed as a sufficient way to account for this. So just thought that was interesting. So I wanted to show this slide here. Again, it kind of reinforces this threshold. So again, this is the original noise standard column, the settings there, and this is the Hearing Conservation Amendment standard. Both standards are in place. Requirement is to monitor both ways. So if you have, which you never have, but if you had a pure sound pressure level of, say, 90 decibels for 8 hours, you're going to have 100% dose, because that's 90 dBA for 8 hours. That's a time-weighted average of 90. But if you could replicate an 89 dBA noise, uniform, never gets to 90 for 8 hours, the dosimeter, the way it's set per OSHA, is going to read 0, which you know, it's just doesn't make a lot of sense, but that's the way it is. Now, conversely, the dosimeter set with an 80 decibel threshold, obviously if it's anything, you know, if it's 90 decibels for 8 hours, you're going to get 100% as well. So if you get 89 decibels dBA for 8 hours, you know, it starts trailing off. The logarithm starts kicking in and everything. But the bottom line is everything above 80 is contributing to the overall number that you're going to get on your noise dosimeter. And of course, if it gets below 80, then it's not going to record anything either. Now, keep in mind, again, since it's logarithmic, really noise levels below 80 decibels is not going to contribute that much once you start getting up to 85 and 90. So just the way that the logarithm scale works. So now I want to talk about results interpretation. When you get your, when you're looking at your noise dosimeter, or you get a printout, which by the way, there are two ways you can get the data off a noise dosimeter. You take it off the employee at the end of the day. You can actually toggle through the dosimeter and get and just write the numbers down, or you can download the data and print out the results. I'd recommend in general, if you're able to download and print it out so you have a record of it. But some of the key terms, the L average, that's the L stands for level, and then AVG is average. That is the average sound pressure level over the monitoring period. Whereas the TWA, which stands for time weighted average, is the average sound level over the monitoring period, comma, relative to an 8-hour period. That's really critical to note there. So it is the average sound level, but it's relative to an 8-hour period, which I'll talk about in a second, which differentiates that from the L average number. And the dose percent is really just a mathematical calculation that kind of converts your numbers here, your actual decibel numbers, over to dose relative to the 90 decibel criterion level. So I want to look at a monitoring scenario here. And again, this is important so you know what to look for when you're looking at the results off your dosimeter. So let's say that you plan to monitor 10 employees one day for noise exposure, which is a very common thing that we do when we're doing noise monitoring. We'll usually monitor 10 employees. So if your employees work an 8-hour shift and they start at 7 a.m., but by the time you get all 10 noise dosimeters on everyone, the last one, the time you find this employee and you get this person hooked up and you start the noise dosimeter, you don't start it till 8 o'clock. So that employee was out there working in a noisy environment, but you don't get them started until 8. All right, and then you take the noise dosimeters off at 3 p.m. when the shift ends. So let's look at that 10th employee. At the end of the shift, the dosimeter for the 10th employee shows the following: a duration of 7 hours. All right, the TWA, when you look at it, is 84.1, whereas the L average is 85.2. So your first inclination would be, well, I'm measuring the 8-hour time weighted average exposure for this employee, so I'm going to write down 84.1. Well, that's lower than the OSHA action level. They don't have to be on a hearing conservation program. Well, that would not be the correct way to look at that. And the reason is the way a noise dosimeter calculates this TWA relative to an 8-hour period, all it knows is I've got 7 hours of data, and I've got to compare that to, I've got to make that relative to 8 hours. So it's basically saying 7 hours at the L average of 85.2 plus 1 hour at 0, because, you know, it's relative to this 8-hour period. But keep in mind, now if OSHA did that, they probably would have to use that number because they can't make any assumptions at what they don't monitor, from my understanding. So, however, this employee was being exposed for an hour before you got that person hooked up, whether he was wearing the dosimeter or not. So this L average is the average over that 7-hour period. But if the employee was out there doing the same thing in the same area, then it's pretty safe to say that if you had that dosimeter on that person for 8 hours, then the TWA would also be 85.2. So you could make a false, or a bad decision there by assuming I should just look at the TWA. And of course, the more off that is, the bigger that disparity would be. If that was, say, 6 hours, this TWA would be something like, probably 81 or 82 instead of 85.2. So basically, if it had been 8 hours exactly, it would be exactly the same. If the monitoring period is less than 8 hours, the TWA is always going to be less than the L average. If it's more than 8 hours, it's going to be more than the L average. So I think I had these questions, but we pretty much answered them all already. So which do you use to determine if the action level was exceeded? I would use this one because that represents the true exposure over that 8-hour period. And here's an actual noise dosimeter printout. This is from a Casella, and you've got some stuff down here that really what I want you to focus on is L average and the TWA. If you notice this, in this case, the period was 7 hours and 44 minutes. And so as I mentioned earlier, these dosimeters, I think I mentioned it, but they have different channels that are set for the different parameters. So this is set for the hearing conservation standard. This is set for comparison to the OSHA PEL. And so we're just 16 minutes different, off from an 8-hour shift. So the numbers are going to be not nearly as much as before, but as you see, the L average was 86.9. The TWA, that extra 16 minutes, lowered it by 0.2 decibels. And kind of the same thing over here as well. So just so you know, you should really use this L average for your result. So here's another monitoring scenario to cover kind of the same thing. You got 10 employees, but this time they're working a 12-hour shift, and they start at 6 a.m. You get the last employee hooked up at 7, but they go ahead and wear it the rest, the rest of the shift. So you take it off at 6 p.m. So at the end of the shift, the dosimeter for the 10th employee shows the following: a duration of 11 hours. Now look at the difference in these, and these are actual numbers that were pulled off of a dosimeter. The L average was 81.3, but your TWA was 85.5. So pretty big difference there. But why was the TWA higher than the L average? Well, the reason is that this noise dosimeter, it's trucking along. It gets 8 hours of data, and it's running. You have to assume it's running right at 81.3. Well, then you've got 3 extra hours there that's integrated in, because it's relative to an 8-hour period. So it actually, you end up with a bigger number. So which result reflects the average exposure for the 12-hour shift? Well, it's really this one, assuming you think that 1 hour you missed was similar to the 11 hours that you monitored. So anyway, yeah, this would represent their average exposure over the shift. So was that employee exposed above the action level? Well, we're going to talk here, I think in a couple of slides, on how you have to adjust the action level for extended work shifts. But even at that, it would be 82 decibels for a 12-hour shift. So no, they're below it, barely below it, but they are below the action level. And this is another one. This is again, this one just barely over. It's 9 minutes over 8 hours, but you'll see a slight difference, kind of the same thing. That's why the TWA is bigger than the L average. Same thing over here. So what about extended work shifts? We want to go from an 8-hour work shift to a 12-hour work shift. How does that impact I guess the potential for harm to our employees? And from a regulatory standpoint, what does that do? Well, from the OSHA PAL, the original noise standard, there's no adjustment based on shift length. So you do not have to do anything there. However, with the action level, the Hearing Conservation Amendment, it must be adjusted for extended shifts, longer than 8 hours, because it's based on 8 hours. So there's a mathematical formula for it, but really what you need to know, unless you have some kind of unusual number, a 9 or 11-hour shift, but for the most part, most companies work either 8s, 10s, or 12s. So the 10-hour adjusted action level, if you plugged 10 in there, you're going to get 83.4, and the 12-hour action level is 82. So if you go to a 12-hour shift, your action level is going to be 82, and that's why you would take the L average, and for the monitoring period, in general, unless you know that the unmonitored portion of the shift is 0, where somebody consistently stays in their office or whatever, but generally, conservatively, we just assume it's going to be the same, because again, employees are exposed whether we have a dosimeter on them or not, if we happen to not get it on them for the full shift. So anyway, I think that's all I wanted to say about that slide. I do want to look at ACGIH, which again, the original noise standard was based on the ACGIH TLV for noise back in 1970, but ACGIH, when they get better information, you know, more up-to-date information on the damage from, you know, whether it's air contaminants or noise or whatever, you know, it's not an act of Congress, so to speak, to change it. They put out a notice of intended change, and it's they're updated frequently when it's warranted based on the empirical data of either harmful air exposures, noise exposures, whatever. But it's a significant difference in how the results are interpreted. And we'll say that the EU, European Union settings are very, very similar to ACGIH. So got this next slide we'll take a look at. Just so you can see the difference between OSHA. We talked about that plenty, but let's look at ACGIH. It's a TLV of 85, and it's actually, that is their criterion level. So if you have a noise dosimeter that has dose for this setting, when you see 100% dose, that means 100% is 85. So difference here where, you know, 90 is the criterion from OSHA. But here's the biggie right here. It's an exchange rate of 3 decibels, and that has a tremendous impact on what the results are when you get them off a dosimeter. It's always going to be a bigger number than OSHA, because essentially they're mathematically, it's actually accurate that let's just say a 10 decibel increase is a little over 3 times louder. And again, that from a physical and mathematical standpoint, that is correct. Whereas OSHA is saying, well, we're using a 5 dB exchange rate, and it's only twice, you know, it's every 5 decibels. Still slow response. And oh, I did want to mention why it was slow response. Again, that's always been, from my understanding, at the original noise standard, that they use these analog meters and they just couldn't keep up with it. And so they've just kept that, and I don't think it really impacts too much there. But ACGIH also has a threshold of 80 dBA, and again, a criterion time of 8 hours. So there is a formula for adjusting the TLV for extended work shifts as well. So here's a real world comparison. We'll look at some data. You know, this noise dosimeter has 3 channels, and as I said, you know, noise dosimeters, they have one microphone, but they have these different channels that they integrate and report out information based on, typically, they come from the factory set this way on the hearing conservation standard settings, the original noise standard with the 90 decibel threshold, and then with ACGIH. So most any dosimeter you get nowadays will have these 3 channels. So obviously it's very important. If you're toggling through your noise dosimeter and you're writing down numbers, you got to know, oh, am I looking at the channel 1 hearing conservation numbers? Am I looking at the OSHA PAL numbers? Am I looking at ACGIH? Because it makes a big difference. So these are like some real numbers from a dosimeter. And this is one person wearing this dosimeter over roughly 8 hours. And so it's the same noise going in this microphone, but you get a 83.4 dBA number, L average, that's what it would be, 83.4. The OSHA PAL, because they're not getting that 80 decibels and up, it's only getting 90 and up, it's way lower. And then ACGIH, since you have everything's the same here to here, except it's got a 3 dB exchange rate. So it's 85.7 compared to 83.4. And I've looked at literally thousands of noise results, and just depending on what the noise levels are through the day, they'll always be in this order. This is the biggest number, this is going to be next, and then this one's next, the lowest. But usually from the OSHA hearing conservation with a 5 decibel exchange rate to the TLV with a 3 decibel exchange rate is usually always at least 2, and it's sometimes 5 or 6 decibels difference. So was the action level exceeded? This employee wore it. Well, it's kind of a trick question, because you have to know, did my employees work an 8 or 12-hour shift or 10? Well, if they worked an 8-hour shift, no, because that's below 85. All right. If they worked a 10-hour shift, they equaled it, and since the standard says at or above, then they're at for a 10-hour shift. And for a 12-hour shift, they're over. So they would be over as 12-hour shift. The OSHA PAL, obviously way below 90 decibels, so nothing to worry about there. But the TLV, yes, it's over the limit there. And here's just wanted to show you again. This is a printout. It's actually the same one. I just pulled it over where you could see this third channel. Again, same employee. You had an OSHA hearing conservation number of 86.9. The OSHA PAL comparison number is 84.6, and then your TLV number, ACGIH, was 91.9. So you can just see the difference there. So just a few little things. This is the last slide that I thought was interesting. This comes out of from ACGIH, their current TLV booklet. Exposure to certain chemicals can cause hearing loss and can have synergistic effects with elevated noise exposure. I just wanted to throw a few of these things in here just to further, I guess, discuss the importance of controlling noise exposures in the workplace. But you can have certain chemicals. Xylene, I think, is one that's known to do that. If you have exposures to xylene and you have elevated noise, it makes the noise damage worse. Evidence suggests that TWA exposures in excess of 115, that's DBC, that's not an A scale, but to the abdomen of women beyond 5 months pregnancy can cause hearing loss to the baby. Now, 115 decibels, that's really, 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 really loud, and it's saying a time-weighted average, so I could certainly see how that could happen, but it's kind of interesting that they pointed that out. Chronic noise exposure, less than 85 dBA, may be associated with elevated blood pressure, hypertension, and heart disease. So less than 85, can still cause issues, like it might be 80, might be 78 to 80, but if you're exposed to it day after day, it can still cause some problems. And then noise exposures above 85, obviously, and again, this is a TLV, so we're looking at the 3 dB exchange rate. You're going to get to that a lot quicker, but noise exposures above 85 decibels may be associated with risk of injury through distraction, stress, fatigue, and other mechanisms. So many reasons beyond just damaging your hearing that you need to control noise exposures in the workplace. So with that, that's the end of the presentation. Thank you once again for participating in this, and let me know if you have any questions, and
Bayless, we're right up against the hour mark, but there are a few questions in the Q&A. Are you able to view those?
If I can figure out how to do it.
I think if you hit the Q&A button on your toolbar.
Yeah, after noise assessment, it's been revealed an employee is exposed to a high level of noise. What if an employee rejects wearing head muffs? So I presume maybe this is, well, first of all, you have to offer several different types of hearing protection to the employees. And so I'm presuming maybe this is where it's a really loud noise source and the employee's already wearing hearing protection like earplugs, but you're wanting them to wear double hearing protection, you know, muffs over the plugs, but they just won't do it. Then I think in my opinion, you would have to reassign that worker, or again, you start getting into some of the legal things, but let's just say that employee says, I'm refusing to wear my PPE. That's essentially what they're doing. They're saying, I'm refusing to wear PPE. And so you can't have employees just refuse to wear PPE. You're going to have to address that with them. Is there a difference between record keeping requirements for air and noise exposure data? Yes, there is. In the noise standard, it surprises me, but the noise standard does say that you just have to keep noise exposure records for 2 years, which we would generally recommend you keep them longer than that, but it is in the noise standard that record retention is 2 years, which again, you have to remember these noise standards were adopted, you know, in the 70s and 80s, and it reflects kind of what was going on at that point in time. And if they've not been updated, then they're outdated. So I would recommend keeping them longer than that, but from a regulatory standpoint, you would not have to. Is occupational hearing loss a recordable injury? Absolutely, it can be. Yes, and there's a definition of what constitutes a standard threshold shift that would equate to a recordable injury. So yes, you can have a lot of recordables in a year if you do your audiograms and you have these standard threshold shifts, which again, I will say, it's why monitoring is so important to have data to potentially rebut whether it occurred at work or not, because whether you're being exposed to loud noise at work or whether you're, you know, on your lawnmower, you're out, you know, you're in a, you know, shooting your guns, whatever, racing cars, you know, whatever, after hours, the symptoms are the same. So it's sometimes, and that, believe me, a lot of companies fight that battle all the time. Like, okay, we don't think your injury occurred at work because, you know, we got monitoring data or we're requiring the hearing protection that's adequate. So yes, it can be a recordable injury.
Thanks, Bayless. And thank you everybody for attending today. Just a few notes. This webinar and all of our webinars will be recorded and will be viewable on EnSafe's website. You will all receive a certificate. If you register for this course, you will receive a certificate emailed to you for 1 hour of professional development. And I will also be sending out a link to a brief 4-question survey for you to provide us feedback. Again, any feedback is greatly appreciated. And please stay tuned or tune in next week. Our topic title is Machine Guarding Fundamentals for Auditors and Inspectors. And once again, thank you for joining us. Thanks, Bayless, and enjoy the rest of your day. Enjoy the rest of your week. And this concludes the presentation.